Now let's just do a quick review right here on this video. The first fact that we already all know: to find the inverse of any function, switch x and y and solve for y. Next fact, inverse notation is simply this right here. F, it looks like an exponent, a negative exponent, or negative 1 as an exponent, but that's really just inverse, right? So if you see f with that little negative 1 up there of x, it's really telling you to take f of x and to find the inverse. Now what does that mean, find the inverse of f of x? You switch x and y and solve for y. So this is just the notation right here. And the next one says to find the inverse of any set of coordinates, simply switch x and y values. And also, by switching x and y values, the coordinates get reflected over the line y equals x. And that kind of makes sense, because if you're switching x and y, you're kind of like saying that they're equal in value, y equals x. But we'll go over these in more detail in a couple of seconds here, a couple of minutes. And the last one is the new one, where if I give you two functions, f of x and g of x, and I ask you to verify if they are inverses of each other, what you have to do is take the g of x function and plug it inside your f of x function, and everything should cancel out except for the letter x. And likewise, then you have to take the f of x function, plug it inside your g of x function, and everything cancels out except for x. That's what this is saying down here. F of g of x equals x, g of f of x equals x. If that's true, then f of x and g of x are truly inverse functions of each other. So let's start with the first fact. So let's say you have a function f of x equals 3x minus 2. And let's say, even before finding the inverse, let's just graph it. So the first thing to do would be, remember, f of x is the same thing as y. So let's graph y equals 3x minus 2 using our algebra 1 skills. Where does it cross the y-axis? Negative 2. Okay. So let's put a dot at negative 2. Now what do I do from that point? Up 3. 1, 2, 3 over 1, right? So technically we have a coordinate at 0, negative 2, and a coordinate at 1, 1. And we could keep going with that pattern of up 3 over 1 to extend this line, or even backwards, down 3 over 1 the other way to extend the line as long as we want. And there's our graph. Just a little review of graphing lines. Okay. Now, if I wanted to find the inverse, okay, so remember, originally this guy was called f of x, so they could tell you find f with a little negative 1 of x. That's really telling you to find the inverse of the above function, right? So that's the notation. That was the second fact you guys wrote down in your notes. So we're going to switch x and y and solve for y. Okay, so to find the inverse, you switch the x and the y and you solve for y. So it's the same exact equation, but instead of y equals 3x minus 2, it's x equals 3y minus 2. All I did was switched the x and y. Now I need to solve for y. So when I solve for y, I need to first get rid of that minus 2 by doing the opposite, plus 2 and plus 2. So you're going to get on the left side of your equation an x plus 2 equals 3y. And last but not least, you need to divide everything by 3. So we're going to divide by 3, divide by 3, and divide by 3. So what we have left is y equals, man, this came out really ugly, 1/3 x plus 2/3. And to write it in a more friendly way, let's put the y on the left. Y equals 1/3 x plus 2/3. There's your inverse of the original y equals 3x plus 2. Do we understand what I just did?
That's it.
That's it. So this equation, if I told you to find the inverse of it, this is the inverse of it. How did I do it? I took my x, I took my y, I switched them, and then I solved for y, and this is my inverse function, okay? So that's how to do it. That was the first fact that you wrote down on your notes. Now, let's move on to the next thing that we had on our notes, which is to find the inverse of any set of coordinates, simply switch the x and the y values. By switching x and y values, the coordinates get reflected over the y equals x line. So there will be a question on your homework today that will ask you to graph your original equation. I just did that. And then they're going to ask you to graph your inverse of that original equation. So graphing with this, it gets a little ugly because what's your b value? Where does it cross? Where does it cross at? 2/3. So when you think about crossing at 2/3, you're talking about 1/3, 2/3. It's not even all the way up there to 1. It's 2/3 of the way up. Does that make sense? And then from that point, you'd have to go up 1 to the other 2/3 spot, and then over 3, 1, 2, 3. Then you could draw your line. However, there's an easier way of graphing the inverse. If you already have your original graph, here's your original graph. Remember, the inverse is simply switching your x and y. So I have several coordinates on this black original line. Even this one over here is 2, 4. So you only need 2, but you could get as many coordinates as you want. And what you could do is find the inverse of the coordinates so you could actually graph the inverse on your graph. Okay, so like let's say I told you graph the inverse of this guy. Well, you graph this. You already have it in slope-intercept form, so you could go through and crosses at 2/3. It goes up 1 over 3. But the easier thing to do, if you already have the original graph, is to simply switch your x's and y's. Okay, so instead of the coordinate 2, 4, what would be your new coordinate? 4, 2. So if you go to 4, 2, 1, 2, 3, 4, 2, you end up right there. What if I switch the next coordinate 1, 1? It would still be the same, 1, 1. How about the next coordinate 0, -2? If I switched it, what would it say? -2, 0, which would be right here. And how about, I guess that's good enough right there to draw my line. And that is the inverse. This inverse function is graphed right there with that red line. Okay, now notice that this line that I drew by just simply switching x's and y's, it really does have a y-intercept of 2/3. It really does go up 1 over 3, right, to the next 2/3 spot. So this is graphed right there, but I didn't even actually use this graph to graph it. I used the original because I know, based from our notes, that switching the x and y's on the coordinates produces the inverse, all right, on a graph, visually. You get it? Okay, so let's move on to the next fact of our notes. By the way, before we move on, let me explain something else here. When you look at a graph and the inverse of that graph, what it ultimately is a reflection over the y equals x line. Let's think about that. What is an inverse? It's simply switching x and y and solving for y. Or the inverse of a coordinate is simply switching x and y. So in a sense, we're saying that y and x are equal to each other. Now if you think about the line y equals x, I mean, you could put a +0 if you want to help you out. That would be a perfectly diagonal line going through the origin, going through the 1, 1, the 2, 2, 3, 3, 4, 4, and also a negative, -1, -1, -2. So you have this perfect diagonal, which is the line y equals x. Now, what ends up happening when you graph the original and its inverse, what happens is it gets reflected on this blue line, the y equals x line. Now, you don't have to draw this on your homework or on the quiz, but it's just something that you should know, that this dot up here got reflected. Look, it's equally distant from the blue line as it is down here. It got reflected over here to this side. This one got reflected over that line, which means it's the same dot. This red dot over here got reflected over the blue line. So this part of the line, this part of the red line got reflected over to this part of the black line. Does that kind of make sense? The y equals x diagonal is going to end up being the reflection, the symmetry line, the reflection line when you're comparing an original graph with its inverse. Let's move on to the new part of inverses, which is the last part of our notes today. The last part of our notes say, in order to verify that f of x and g of x are inverses of each other, you must verify that f of g of x equals x. That means I need to plug in g of x into my f of x function, and everything should magically cancel out except for x. Likewise, I also need to verify that if I plug in the f of x into my g of x, everything magically cancels out except for x. So to demonstrate that, let's go to this that we already verified. I mean, we took this equation, y equals 3x minus 2, and we found the inverse, right? That's something that we know, we did it, we found the inverse. So let's pretend that we didn't know that that was the inverse. Let's just say we had f of x was the function 3x minus 2, and let's say g of x was the function 1/3 x plus 2/3. So let's pretend that we didn't know that these guys were inverses of each other. And let's pretend that I gave this to you on a quiz. Let's say I told you there's f of x, there's g of x. So let's pretend that they're asking us to verify that these are inverse functions. Now we already know that they're inverse functions because we found the inverse. We found this inverse and it was that. So let's pretend we didn't know that and they want us to verify it. So according to our notes, we need to verify that these are inverse functions by plugging one function into the other and making sure that everything is just equal to x. So the first thing to do would be to do f of g of x. So I want to take my g of x function and plug it into my f of x function. And so what am I going to do? I want to take my g of x function and plug it into my f of x function. So here's my f of x function. I'm going to rewrite it. I want to write it as 3, but instead of x minus 2, I want to put parentheses minus 2. You guys agree that this is my f of x function, right? It's up here, 3 parentheses minus 2, 3 parentheses minus 2. Now if I would say find f of 5, all you would do is plug in a 5 right here, 3 times 5 is 15, take away 2, you get your answer. But I'm not asking you for f of 5, I'm asking you for f of g of x. So I'm going to take my g of x function, which is this guy right here, and I'm going to plug it into my f of x function, and that's why I put some pretty big parentheses right there. I'm going to end up with 1/3 x plus 2/3. Are you with me? So that is truly f of g of x. I'm taking my g of x function, and plugging it into my f of x function. I'm taking my g of x function and plugging it into my f of x function. So here it is, 3 times that binomial minus 2. That looks ugly, but when you work it out, if you distribute 3 times 1/3, the 3's cancel and you just end up with x. And then 3 times 2/3, the 3's cancel and you just end up with a plus 2. And then at the very end, you have a minus 2. So what happens with the plus 2 and the minus 2? They cancel out. And ladies and gentlemen, we truly are left with just x. So are we absolutely certain that these are inverse functions of each other? Not yet. Why? Because we've only done f of g of x. We still need to do g of f of x. So we still need to do g of f of x. So this other one says plug in your f of x into your g of x. Right? That's what it says. Plug in your f of x into your g of x. So my f of x is this, and I'm going to plug it into my g of x. So let me rewrite my g of x, but instead of the x, let me put parentheses, and a pretty big parenthesis because this is a binomial. So there's my g of x function. All I'm going to do is plug in my f of x function into it, the 3x minus 2. I'm going to plug it right into those parentheses. After you plug it in, we're going to distribute the 1/3. 1/3 times 3x, the 3's cancel. You have a nice beautiful x. 1/3 times negative 2. You actually put the 2 over a 1 and multiply top with the top, bottom with the bottom. You're going to end up with negative 2/3. And you bring down the positive 2/3. And what happens with the negative 2/3 and the positive 2/3? Cancels out, and you're just left with x. We have verified that they are inverse functions of each other because when you plug them into each other, they both cancel out and just give you x. Yes.